Now we are going to expand these exponential terms. The formula for expanding the exponential terms is e raised to j theta, that can be plus minus, is equal to cos theta plus minus sin theta into the imaginary term. As this term is imaginary, it will be j sin theta. So after expanding, we finally get cos pi k by 2 minus j sin pi k by 2 for this term, plus 2 into cos pi k minus j sin pi k plus cos of 3 pi k by 2 minus j sin 3 pi k by 2. Now we know that sin pi k is always equal to 0. So we finally get cos of pi k by 2 plus 2 cos pi k plus cos 3 pi k by 2 minus j, that will be the imaginary terms of sin pi k by 2 plus sin 3 pi k by 2. Now we are going to substitute the value of k, that ranges from 0 to 3. First, we will substitute k is equal to 0. So it comes out to be x of 0 equal to cos of 0 plus 2 cos 0 plus cos 0 minus j sin 0 plus sin 0. This whole term is 0. So the imaginary term turns out to be 0. Cos 0 value is always 1. So finally we get 1 plus 2 plus 1, that is equal to 4 minus j into 0. So it comes out to be 4. When k is equal to 1, x of 1 is equal to cos of pi by 2 plus 2 cos pi plus cos of 3 pi by 2 minus j sin pi by 2 plus sin 3 pi by 2. Now substituting the values of the cos and the sine angles, we finally get cos pi by 2 is always 0. So it comes out to be 0 minus 2 plus 0 minus j sin pi by 2 is 1 and sin 3 pi by 2 is minus 1. 1 minus 1. So finally we get minus 2. When k is equal to 2, we get x of 2 is equal to cos pi plus 2 cos 2 pi plus cos of 3 pi minus j sin pi sin 3 pi. We know that this term will be again 0. Finally, after substituting the exact angles and values, minus 1 plus 2 minus 1 gives out to be 0. And finally, when k is equal to 3, x of 3 is equal to cos of 3 pi by 2 plus 2 cos 3 pi plus cos of 9 pi by 2 minus j sin 3 pi by 2 plus sin 9 pi by 2. Again, we get the values as cos and sin. So it comes out to be minus 2. Finally, the DFT of the sequence comes out to be x of k is equal to 4 minus 2 0 minus 2. We can also plot the magnitude spectrum and the phase spectrum. For magnitude spectrum, we need to calculate the angles, that is converting the rectangular coordinates to polar coordinates. So it comes out to be 4 angle 0, 2 angle pi, 0, 2 angle pi. For magnitude spectrum, we also know that to calculate the magnitude, we have to find mod of x of k. That is, if for example we have 4 minus 2j, so for calculating the magnitude, we have to square both the terms. 16 plus square of 2, that is 4, that comes out to be root 20. Basically the formula is root of x square plus y square. So we'll calculate the magnitude spectrum of each of the term. It comes out to be 4, 2, 0 and 2. Again, for phase spectrum, the angle should be calculated. So angle of x of k, that is given as 0, pi, 0, pi. So we have got the points to plot the magnitude and the phase spectrum. So let us plot that. So for plotting magnitude and phase spectrum, we will refer this magnitude and the phase. So plotting the magnitude spectrum, we will refer to the points of 4, 2, 0 and 2. So the value of magnitude spectrum at the point 0 turns out to be 4. For 1, the magnitude is 2. For 2, the magnitude is 0. And for 3, the magnitude is 2. Again, for plotting the phase spectrum, we will refer the phase values, that is the angle x of k. For point 0, the value is 0. For point 1, the value is pi. For 2, the value is 0. And for again the 3, the value turns out to be pi. So finally we get the DFT of the sequence, that is 4, -2, 0 and -2. And we have plotted the magnitude and the phase spectrum. Thank you.